We have taken this maximum problem to understand the time complexity better. We started from n cube, then we went to n square. Now we are going to try even more optimization and reduce this to O of n. I will put this n cube and n square algorithm videos into the card. Please do watch it. Let's reiterate the problem statement again. So this is very classic problem. We have n elements. We need to find the maximum subarray sum where all the elements are consecutive. So this is the maximum sum we can have. Sum is going to be 18. We cannot select 2, 4, 10 and 7 because these elements are not consecutive. We need to select this minus 5 so that we can get the sum 18. Now we are discussing the final solution. In the previous video, we managed to remove the iteration on k and we reduce the time complexity to n square. Now in this video, we are going to reduce time complexity from n square to O of n. The time complexity is majorly because of the inner for loop. Now for n square solution, we have two for loop. The start one and the end for loop, right? This is inner for loop. This is external for loop. So we have two different for loops, one inside the other. And both of them are running n times. So it takes n square time complexity. So we need to reduce this somehow. Here first we are going to build the logic. Now consider the problem of finding the maximum sum subarray that ends at position I. Now there are only two possible combinations, right? Either that subarray only contains the ith element. Imagine you have this array and this is your ith position. Correct? And what we are saying? We are saying that we want to find the maximum subarray sum that ends at position I. That means any array like this or maybe like this, we don't know. But what we know that it ends at element I. That's what we know. So there are only two possible combinations. What are those combinations? Either we include only this element I or we include something before it plus element I. That means maximum sum array till I minus 1 and you include this I value into this, right? These are the only two possibilities. Either you start from here and end at here or you start from somewhere else and end at here. Ending is fixed. Correct? That is going to be the ith position. Start is not. Either you are going to start from here and end at here. That means you select only one element. Or you start from any position. But you have to end at this position. So where are you exactly going to start? So our end is fixed, we know. We are worried about start. So where exactly are you going to start? Where? For I minus 1, let's say we know the maximum subarray sum that ends at I minus 1. And this is your I minus 1. And you know that if you take these elements, then your sum is going to be the max among all the possible combinations. This is a possible combination. This is a possible combination. This is also a possible combination by selecting these two elements only, right? You can select all 5 elements. You can select 4 elements. You can select these 3 elements. You can select these 2 elements. You can select this single element as well. But among all possible combinations that ends at I minus 1, we know that if we select this particular subarray, we get the maximum sum. Then for ith position as well, we are going to select this as a start point. We are going to select this particular segment. We don't select this particular segment. Why? Because we know for the I minus 1, this provides us the largest value. And we want to find the largest value. So we take the largest value till I minus 1 and add ith position into it. Correct? Let's say this is our starting point x. Let's say this. And this is our starting point y. And this is our ending point I minus 1. And this is our ending point I. Now imagine this. This is I x to I minus 1. We have the largest sum. Assume that. We have the largest sum for x to I minus 1. What I am going to prove to you that if you select any other y, any other starting point other than this x, you will have less sum. Why? Let me compare. Let's say sum, right? Plus what you will have? You will have ith element. Correct? Now let's say you select any other segment. You select starting from y till I minus 1 plus ith element. Now what I am trying to say is that this will always be greater than this. How? This I and I will be cancelled. The value of ith element is not going to change, right? This ith element, this ith element. Now we know that sum starting from x index till I minus 1 index is greater than sum starting from yth index till I minus 1 index. We know that. So you always select whatever the max subarray sum till I minus 1 was. You take that sum and you add that value to ith position. So there are exactly two possible combinations. You start from here and you end here. That means you only select one element, that is your ith element. Otherwise, you start from somewhere which worked out for I minus 1. You start from there. These are the only two possible combinations to have maximum sum of subarray that ends at position I. And that's what we are going to use to develop our algorithm. So this is the logic that we have. This is our observation. Now we are going to convert that logic into the code. We are going to store this maximum sum of subarray ending at position I into an array called as sum I. Our answer is going to be maximum among all possible combinations of sum I. Because when you select a subarray, it's going to end at some index, right? And we are computing the maximum sum ending at ith index for all I, starting from 0 till n minus 1. Our answer, whatever that is, we don't care. Our answer is going to end at some index, right? We have computed the max subarray sum for every single index. So you take the maximum value among those and that's going to be your answer. I hope this is clear. Now let's look at the code. You need to spend some time with this code to understand. Very easy, very simple, but when you look at it first time, it looks tricky. You spend some time with it. Okay, so now we have two variables, our answer variable and our sum I variable. Sum I represents the maximum sum of subarray that ends at index I. Okay, initially it's going to be 0. So we are going to start our iteration. I will go from 0 till n. So sum I currently stores the maximum subarray of sum ending at I minus 1, right? Because for ith we are updating now. That means sum I is storing till I minus 1, correct? So you have only two possible combinations that we have already discussed. Either you select this element only as a start and end that we have written here. Or you have another option that you take whatever the maximum subarray sum till I minus 1 was, that is this, and you add your ith value into it. So whatever is the max is going to be our maximum subarray sum ending at index I. That's what we are updating here. I hope this is clear. See, we have only two options. You start here, you end here. That is taken care by this value. Or the other option is you take whatever the maximum subarray sum till I minus 1 was and you add your current value into it. These are the only two possible combinations that you can have. Because our end is fixed. Our start is varying. Our start can be from this particular index itself or it can be from any other older index. But we are not going to check for all the older index because for I minus 1 we know what works the best. For I minus 1, this particular segment, this particular index gave the largest value. So we are going to use this exact same index for computing maximum subarray sum ending at I as well, right? Let's dry run our code onto this example. So our sum I is going to be minus 100. How? See, initially it's going to be something very small. Here I have initialized it with 0, but it should be a very small number like minus 10 to the power 9, something like that, because we have negative numbers with us, right? Now let's try to dry run our code. See, sum I is going to be minus 100. So our end is fixed. So you have only two possible combinations. Either you start from here itself or you start from any other index before it. Well, there is nothing before it, so you have to start from here. That's why sum I is going to be minus 100. Best value is still 0. Okay. Now you go to the next index. Now you have two possible combinations. Right, your ending is fixed. So you start from here itself. That means you select only this particular value, or you start from any other element previous to it. So now you compare what you are going to select. You are starting from here, which worked out for I minus 1, or you start from here. Definitely you are going to start from here, right? If you select this particular entire section, you have minus 98. Even though this worked out for I is equal to 0, but it's not going to be working for I is equal to 1 because we have a better value 2. So sum I is going to be 2. Now we'll update our best value. What will happen for 4? Again you have two possible combination. You start from here or you start from any other index before it. So if you start from here itself, you have the maximum value as 4. Correct? But if you start from any other previous index, we will check what worked out for I minus 1, that is for the index 1. Wait, what worked out for the I minus 1? So starting from here, index 1 worked out for the I minus 1, and that's how it got value 2. So okay, we start from here and we check. We have 2 plus 4, 6, which is better than starting from here. Now you try to do this for all the other index. Now if you look at all possible sum I values, this 18 is the max. And that's what our answer is.